morning to one and all present here. Myself Soundarya Chokalingam and my teammates are Shakti Shri N and Shobana T. We are guided by Dr. D. Shivakumar, internal guide, Professor Department of Civil Engineering, Vtht Head Engineering College. Externally we are guided by Mr. G. Shivakumar, ME, Project Head and Coordinator, ICOMAT Taramani. Our project is Durability and Mechanical Characterization of Concrete using alcofines. Aim of our project is to evaluate the performance of concrete containing a supplementary cementitious material called as alcofines. It is nothing but ultrafine GGPS. The durability and mechanical characterization of concrete with partial replacement of alcofines is done. Objective: use of alcofines as a partial replacement for cement to show the variations in mechanical properties and durability effects is the main objective, and also to find the durability of concrete with alcofines against the normal concrete. The scope of the project is that today most of concretes contain a supplementary cementitious material that make up a portion of the cementitious component in the concrete. These materials are generally byproducts from other process or natural materials. For use in concrete, supplementary cementitious materials, sometimes referred to as mineral admixtures, are added to meet the requirements of the established standards. These may be used individually or in combination with the other materials. Unlike the other mineral admixtures, microsilica and alcofines are byproducts from the industries where the engineering values are well controlled, and as they are byproducts, they are more useful and just they are slag. Therefore, using microsilica and alcofine in concrete should promise advantages compared to other supplementary cementitious materials. Alcofines. Alcofines is a new generation ultra-fine low calcium silicate product manufactured especially in India. It has distinct characteristics to enhance performance of concrete in fresh as well as in hardened stages. It can be considered and used as a particle substitute for silica fuel. The literature reviews. Following the literature we have collected, the first goes with study on durability of high performance concrete with alcofines and fly ash, the authors of which is Yatin H. Patel, P.J. Patel, Professor Jinesh M. Patel, Dr. H.S. Patel. The effect of alcofine on self-compacting concrete is the next paper, and the author of which is M.S. Pawar and A.C. Saoji. The third paper is experimental study on high performance concrete with mixing of alcofine and fly ash, the authors of which is Deval Zoni, Suhasini Kulkarni and Vilan Parekh. The next paper is followed by an experimental study of strength relationship of concrete cube and concrete cylinder using ultrafine slag of alcofines, the authors of which is Saurav Ashok Kumar Gupta. The tests to be conducted are as shown here: aggregate test, specific gravity test according to IS 2386 Part 3 1963, water absorption test and sieve analysis of the same, concrete test, compressive strength test, water penetration test, RCPT, rapid chloride penetration test, confined to ASTM C1202, flexure strength test. Specific gravity test. Specific gravity is the ratio of weight of a given volume of concrete or aggregate to the weight of equal volume of water. The specific gravity of aggregate is used in calculating the percentage of voids and the solid volume of aggregates in computational of E. Water absorption test. This test helps to determine the water absorption of coarse aggregates as per code IS 2386 Part 3 1963. The formula used for which is water absorption is equal to A minus B divided by B into 100%. Sieve analysis. Sieve analysis is nothing but the gradation test. It is a practice or procedure used commonly in civil engineering to assess the particle size distribution of granular material for both fine and coarse aggregate. Compressive strength test. A compression test determines the behavior of materials under crushing loads. The specimen is compressed and deformation at various loads is recorded. Usually a cube of size 150 by 150 is used. Water penetration test. Water penetration test involves subjecting one end of the unsaturated concrete to a pressure head. The measuring of the water penetration is achieved either by measuring the volume of water entering or by split opening the cylinder and measuring the average depth of discoloration due to wetting taken as equal to the depth of penetration. RCPT, rapid chloride permeability test or penetration test. This is confined with according to ASTM C1202. It is performed by monitoring the amount of electrical current passing through a sample of 50 mm thick by 100 mm in diameter in 6 hours. The sample is typically cut as a slice of core or a cylinder. The voltage of 60 volt DC is maintained across the ends of the sample throughout the test. One lead is immersed in a salt 3% of NaCl solution and other in 0.3 molality of sodium hydroxide NaOH solution. Based on the charge that is passed through the sample, a qualitative rating is made on the concrete's permeability. Flexural strength test. The flexural test method measures the behavior of material subjected to a simple beam loading. It is usually taken as 2-point loading. It is also called as a transverse beam test, and with some materials, the maximum fiber stress and maximum strain are calculated for increments of load. Results are plotted in a stress strain diagram. Materials: cement. Ordinary Portland cement of grade 53 is used. The cement was tested according to IS 4031 1988. It is conformed to IS 1226 1987. Its properties are as tabulated. Specific gravity is 3.15. Normal consistency is 31%. Initial setting time is found to be 38 minutes. Final setting time is 453 minutes. Fineness is 3%. Soundness is 1.2. And it is found the values are as per IS 12269 1987. Fine aggregate and coarse aggregate. The properties of fine aggregate and coarse aggregate is as summarized down. Coarse aggregate of 20 mm grade and 12.5 mm grade are used. Specific gravity of same is tabulated. The fine aggregate is generally manufactured sand, but we've also taken the specific gravity and total absorption of river sand. The sand used for study, as mentioned, is manufactured sand. The sand is passed through 4.75 mm sieve. The sand conforms to grading zone 2 as per IS 383/1970, reaffirmed in the year 2011. The sieve analysis of the M sand is as given, and the finalized modulus of the same is 2.92. Comparison between river sand and M sand is as given. We have used M sand over river sand due to the following characteristics, and also that the river sand availability is very minimal in the southern region of Tamil Nadu. Sieve analysis of 20 mm aggregate is as given, and the finer limit is as mentioned. The sieve analysis of 12.5 mm aggregate is also given here. Alcofines. Alcofines is a specially processed product based on slag of high glass content with highly reactive obtained through the process of controlled granulation. The alcofines have been used conforming to ASTM C989-99. Physical and chemical properties of alcofines are as shown. Fineness, specific gravity and bulk density are given here. Fineness is greater than 12,000 cm square per gram. Specific gravity is 2.9. Bulk density is kg per meter cube, 700 to 900 kg per meter cube. Table. Chemical properties of alcofines. This is nothing but the chemical composition of the alcofines. CaO, SO3, SiO2, Al2O3, Fe2O3 and MgO are as given. Superplasticizer. We have used superplasticizer Auramix V400, which is specifically used for this study, and it has a unique combination of the latest generation superplasticizers based on polycarboxylic ether polymer with long lateral chains. This greatly improves the cement dispersion. At the starting of the mix process, an electrostatic dispersion occurs, but the cement particles' capacity to separate and disperse increases. This mechanism considerably reduces the water demand in flowable concrete. Auramix 400 combines the properties of water reduction and workability retention. It allows the production of high-performance concrete with high workability at less water content. Experiments on concrete materials. Test on fine aggregate is done as like specific gravity, water absorption, bulk modulus and fineness modulus. The test on coarse aggregate is specific gravity and water absorption, fineness modulus and bulk density. Specific gravity on fine aggregate. The object and scope of this particular test is to test aggregate passing 4.75 mm sieve by pycnometer. The material and equipment used are pycnometer with conical brass cap, electronic balance sensitive 1 gram. Test procedure for the same is according to IS code 2386 part 3. The calculations are done and we found the water absorption value to be 1.87 and specific gravity to be 2.65. These are the testing procedures, and these are the testing procedure for coarse aggregate of 12.5 mm sieve. Specific gravity of coarse aggregate. The objective is to test and determine the specific gravity of coarse aggregate 12.5 mm and 20 mm. The apparatus used are a balance of capacity not less than 3 kg, an oven, wire basket of not more than 6.3 mm mesh, and 2 dry soft absorbent cloths. The test procedure is confined to IS code 2386. The calculations are done and the specific gravity of 20 mm aggregate was found to be 2.68 and the water absorption value was found to be 0.70. The specific gravity of 12.5 mm sieve was found to be 2.71. Bulk density of fine and coarse aggregate are shown. To determine the bulk density, we have used IS 2386, Part 3, 1963. The material and equipments are as given.